All right, so we're in the prerequisite chapter, starting with section 2. We're getting into some integer exponents and their properties. So I have written all the algebra properties that we know so far with these types of exponents and powers, okay? So I'd like you to try to fill in the column with all the examples. You can see I did the first one for you. This is called the product of powers. Remember, product means multiply. So the rule is whenever I multiply two powers with the same base, the rule is I have to add the exponents. So you can kind of see here, when I multiply x to the third and x to the fourth, we have to add the 3 and the 4 and we get x to the 7th. Okay. If you are confused on why that is, don't feel like you can't just write out the expanded form, right? This is 3x's times 4x's. So altogether I have 7x's, right? So x to the 7th. All right. So if you ever get confused or stuck, you forget what the rule is, you can always write stuff out in expanded form, and that should help guide you because you have an exact visual of what's going on. All right, so pause the video, see if you can figure out that column. When you return, I'll have the answers there for you. All right, so you've got a lot of different options here. I'm going to stick with variables for a lot of times, but you can use numbers too if you want. I'm going to do something like, 2 to the 5th over 2 to the 3rd. I have to subtract, so that's 5 minus 3 is 2, so 2 squared, which would be 4. Negative exponents, so if I have something like 5 to the negative second power, this would be like 1 over 5 squared, which we know is 1 over 25. Anything to the 0 power is 1, so let's say 10 to the 0 power is 1. Now, what you have to be careful of is if I have like a negative 10 to the 0 power, that would be negative 1, okay? It would only be true to be 1 if it was negative 10 to the 0 power. That would be positive 1. All right, so just be careful of that. Make sure that negative is inside the parentheses if you want it to be positive 1. Power of products, if I have, let's say, 5x to the 4th power, this would be 5 to the 4th power times x to the 4th power, which would be 625x to the 4th power. Next up, let's do an example with, how about, let's do x cubed raised to the 5th power. Well, this would be x to the 15th power because 3 times 5 is 15. Power of quotients, if I have, let's do x, honestly, this one's probably good the way it is. We can do x over 2 to the 3rd power. This would be x to the 3rd power over 2 to the 3rd power, which would be x cubed over 8. All right, then the last one, whenever you put in something and square it with the absolute value, so let's say I have the absolute value of 3 squared. This would be the absolute value of 3 squared, which is just 3 squared, or 9. All right, so the absolute value is going to make it positive. When you're squaring it anyways, it's going to turn positive, so regardless of what the absolute value does, you're going to have it always be a positive when it comes out. All right, so those are some of the properties that we know already. Just a quick refresher there. All right, so pause the video again and see if you can evaluate these expressions, and when you return, I will explain them. All right, so first thing, we're going to plug in negative 3 here for x. So when we do that, we've got negative 2 times negative 3 to the 4th power. So negative 2 times negative 3 is positive 6. All right, and so we're going to go ahead and we're going to take 6 and raise it to the 4th power. You don't have to leave it in the parentheses if you don't want to. You can, but you don't have to. 6 to the 4th power is going to be 1,296. All right. Next up, we've got negative 3 squared times 9 to the negative 2nd power. So first thing I'm going to do is I'm going to take this negative 3 squared and leave it where it is, but I don't want to have any negative exponents, so I'm going to move this to the denominator and make it positive, all right? So now in my numerator, we've got a negative 3 times 3, so this is a negative 9, all right? If it was negative 3 squared like this, that would be positive 9, but we don't have that situation, okay? You can almost forget about these parentheses here and just think about it like negative 3 squared. So I have negative 9 over positive 81, this would reduce to be negative 1/9. All right, and then letter C, I would look at our 4s and then separately look at our 2s, all right? So if I look at the exponents, the rule is I have to subtract them, right? And I like to think of it as, well, I have 2 more 4s on the bottom. So I'm going to have an extra 4 squared on the bottom. And then when I look at my exponents with base of 2, I know that this exponent of negative 1 wants to become positive, so it's going to move to the numerator. So if that happens, that means that I have a 2 to the 6th already up there, and I've just moved up 2 to now become the positive first power. So this is really 2 to the 7th power over 4 squared. All right, so this is going to end up being 128, because 2 to the 7th power is 128. 4 squared is 16. All right, so now we just have to take 128 divided by 16, and we are going to get 8. And there we go. Those are some of our basic exponent rules. Continuing on to the next page, we do have scientific notation, all right? So with scientific notation, the rule is, all right, we have something times 10 to the something power. All right, we always want to express it like this. Now, this value here is always going to be less than 10. We'll call this value y, whatever we put here. We'll call it y. So it's going to be always less than 10. So like, it could be 9.99999, but it can never be 10. And it's going to be greater than or equal to 1. All right, you can have negative values, so that's okay as well. But the base there, we want that to be greater than or equal to 1 and less than 10. And then this value here can be any integer. All right, so it could be 0, could be positive 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3. You just can't have any fractions in here or decimals, all right? No, has to be an integer, all right? And those are kind of our 2 rules, all right? So I want to write the following expressions in scientific notation. So if I look at where the decimal is now, the decimal is at the end here. So I have to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So if I move it 8 places, that would give me 9.5. And since I moved it 8 places, that'd give us 10 to the 8th power, right? This number is bigger than 1, and this number is bigger than 1. So it's definitely got to be a positive 8th power there. I don't want it to be a negative 8th power. That'd be a really small number, like something you're looking at under a microscope. Letter B, I have to move the decimal point 1, 2, 3, 4, 5, right? Because I want it to be 3.05. And I moved it 5 places to the right. Okay, so again, this number is a very small number, so I need this to also be a very small number. They're both less than 1. All right, this next one is not in scientific notation. It kind of looks like it, but it's not, because this number is not less than 10. So that means I have to make this 2 place values smaller. Right, I made it from 425 to 4.25. And if I make this 2 places smaller, that means I have to compensate for that. I have to make this 2 places larger. So that means this is now going to become a 4.253. I made it 2 places smaller. And then I'm going to have to make this -6 2 places larger. Well, if I increase this by 2, that would turn this into a -4. All right, not a -8. That's 2 places smaller. 2 places larger would be a -4. Write the following expressions in decimal notation. So I would need to move it 1 place to the left. All right, so I'm going to go in this way, making it smaller. So this would be 0.9814. All right, this is written in decimal notation here. All right, that's 9.814 times 10 to the -1st power. Over here, I've got a power of 3, so I'm going to move it right 3 places, right? 1, 2, 3. We're going to fill those with zeros. So this is going to be -4300, negative 4,300. Next one, letter C. 10 to the 0 means I don't have to move it at all. All right, so don't do anything, right? Don't move it. You don't have to. It's 0. The other way to think about this is 10 to the 0 power is just 1. So if I take anything and multiply it by 1, we just get itself. So 1.0008. All right, now the last ones are going to be a little bit of arithmetic involved here. I'm not going to do these all the way through just because it's going to take time to show all the multiplication and everything, but the basic idea is turning these into powers of 10, okay? So if I take this first number here and I turn this into a power of 10, well, I have to move the decimal at the end 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So this is 5.4 times 10 to the ninth. And then if I look at the second number on top, I also want to turn this into a power of 10. So I'm going to go and write this as, let's see, 1, 2, 3, 4. I have to move it 5 places. So 3.6 times 10 to the negative fifth. Remember, it's a negative. It's a very small number. So it's got to be a negative exponent. And then I'm going to look at the denominator. And we can see right here that we got 0.009. So to make this into scientific notation, we would have to move the decimal 3 places to the right. So this would be 9 times 10 to the negative third. Again, it's a very small number. Oops. And then the last one here, we've got 27000. So if I move the decimal 1, 2, 3, 4 places to the left, all right, so let me get the colors here. All right, that's the orange one. That's our last one. If I move this 4 places to the left, that would be 2.7 times 10 to the fourth. Again, this number is much bigger than 1, so our exponent has to be larger than 1 as well. All right. So now I can start doing a little bit of my exponent rules, right? I can start to reduce some things. Okay. So if I look at my 10 to the ninth and 10 to the fifth, I can reduce this, right? We've got 5.4 times 3.6, and then all together, 10 to the ninth times 10 to the fifth, I just subtract those, that's going to be 10 to the fourth. And then in the denominator, we've got a 9, we've got a 2.7, and if I look at the exponents, negative 3 and 4, well, negative 3 plus 4 is 1. So this is just times 10. All right. So what's happening now is that now I can look at the 10 to the fourth and the 10th, and I can say that, well, this is really just, and I can actually start reducing too, right? Because 5.4 and 9 would reduce, 3.6 and 2.7. Imagine if this was 36 over 27, right? I could factor out a 9. Imagine if this was 54 and 90. I could also factor out a 9, right? So there's a lot that we can factor. So basically, I'm going to end up with 5.4 times 3.6 over 9 times 2.7. So there's a little bit of math you might have to do there, but try to do as much reducing as you can. And then if I do some reducing here with the 4 10s on top and the 1 10 on the bottom, that would just give me 10 to the third. All right. So what you're going to do is pause the video and you're going to try this on your own and see if you can come back and figure out the correct answer. All right. All right, so hopefully we saw, and we're going to have 3 zeros on the end here, but if I take 5.4 divided by 9, well, 0.9 goes into 5.4 6 times, and 0.9 goes into 9 10 times. All right. I can take 3.6. I can divide this by 9. 0.9, this would be 4 times. And then I can divide this by 9, and that would give me 3 times. All right. And then we still have the 10 to the third power. So if I reduce, we've got 24 over 30. Hold on one sec. Whoops, sorry about that. Okay. Trying to think of a way to explain this. One thing, okay, it's kind of hard to explain in the video, so maybe I can explain this when I get back to class, but one thing you could do, because I feel like some of you might be getting stuck at this point, is to just straight up multiply these, okay? So try that for now. When I get back to class, I can explain this a little bit better with decimals. Basically, what I'm trying to explain is that 54 over 9 is kind of like, 54 over 90 is very similar to the 5.4 over 9. Okay, so maybe that's coming across in the video, maybe it's not, but this is basically what I'm doing in my head something like this. Okay, so that's what I'm kind of doing in my head and then reducing from there. So if you can do that, if that makes sense to you, go ahead and do it that way. If that's confusing to you, what you can always do, because the goal is to do this without a calculator, right? I would give this to you without a calculator. You could just straight up go, 5.4 times 3.6 and, do all the multiplication down here and then reduce at the end. I think I gave this to you to be a nice answer. But I don't think I conveyed that very well in the video. So we can talk more about that in class when I get back. All right. Okay. So when we multiply this out, we should end up with 800. Okay, so see if you can get 800 by using either of those two methods, but that's what we should get. All right, so I'm gonna have you go ahead right now and pause the video, and then in a second I'll show you the answer for letter B. All right. All right. So let's another big talking point here, okay? If you do this on your calculator, you might get something like this: 1.6 with an E and then a 9. Okay, the E is actually a symbol for scientific notation. So this is actually going to be 1.6 times 10 to the 9th power. Okay, so if you did it on your calculator to check your work and you get this answer, that's what the E really means. It's just scientific notation. Okay, but if you do this out by hand and you change everything to a power of 10 like we did, and you do all your reducing and everything and multiplying, you should get 1, 6, and then if I move this 9 places, we should get 8 zeros. So get your commas in there, and we get 1,600,000,000. All right, so again, do this problem the exact same way as you did example A. If you get stuck, I get that, because we're trying to do all of this in our heads. I was trying to in my head. But if you want to just multiply everything out, you can do that too if the whole, doing that in your head is confusing to you. All right, so that is all for today. When I get back, we are going to do a quick project with scientific notation, and then we'll continue with the notes. All right.